Alright, welcome back to the second last video, seventh video in the BCPC3 solution, or BCPC, solution videos, BCPC3 solution videos. On this video, we are going to talk about the problem Frenemies. So this is based off a Phineas and Ferb song, which I think is a pretty good song, to be honest. But basically, you're given a bunch of people, and a bunch of times two people are going to talk, and when they talk, they become part of the same friend group. So all the friends of both people now become frenemies. And the question is, how many pairs of frenemies are there between each time that there's some pair of people who talks? So, I'll draw a picture here. Kind of explain how that might look. So you're going to have, maybe there are 5 people. And then maybe these first 2 people talk, and they become frenemies. Maybe these 2 people talk, they become frenemies. Now maybe these 2 people talk. So when these people talk, they'll become frenemies, but also they'll become frenemies with all of the other person's frenemies, and all of their frenemies will become frenemies with each other. So you'll have all of these pairs of people. And the number of pairs that get added are like the number of people in this group times the number of people in this group. So the solution to this problem is kind of keeping track of which people or which things are in which group, basically. And if you're able to keep track of which group each person's in and do that in some efficient way, then and you can combine groups, then you can handle that nicely. The thing is, though, that if we just do it naively, so if every time we combine 2 people's groups, we iterate it through everyone in some group and add them to the other person in the other group, then we might add this person to some new group multiple times. So we might add this person into, maybe we add this person into this group. Now we add this person's group into this group, so we add all 3 of them into the same group, right? And now we want to add this person into this group, so now we have to add all 4 of these people into this group. So this one person might be added to a new group n different times, potentially. And the thing is, that's kind of slow, because if each person is added almost n times, then your solution is almost n squared. And since n is 10 to the 5th, that's 10 to the 10th. That's going to take 100 seconds in order to run, and that's going to be too slow. So what we have to do is we have to come up with some way of handling this that doesn't add each person to a new group n times. The other thing we can't do, obviously, is we can't actually keep track of all the edges, because there might be 10 to the 10th edges. We have to somehow keep track of only, like, how many edges there are, or keep track of them in some better way. The lines I drew here weren't all of the edges of frenemies. There would be other edges that I didn't draw. I think that one is the only one I didn't draw. But, yeah. Not really irrelevant. So, alright, how are we going to do this? So let's say when we're combining 2 groups, maybe we have this group and this group. What if we always take the smaller group and we put the smaller group into the bigger group? So let's think about doing that. So in this, maybe this is like some group, and the group is defined by this node right here. Then what we'll do is we'll add all of these things into that list of like the number of nodes in this group. So since this group is smaller, this only has 2 people, and we'll add it into this group. When we do that, the size of this node's group is going to double. So we'll have to iterate through everything in this smaller group. But we know that after we do this smaller group will have a size that's twice as big. So we might still iterate it through it multiple times. Like we might add it to this group, right? We might add all these things to this group. Now there might be some other really big group over here. Now we might have to add all of these 5 nodes to this whole group. But we know that after we do that, the size of this node, the size of its group, will double. And the key thing to keep in mind is that if you keep doubling, then your group size increases at an exponential rate. So when you keep doubling like that, you can only double 20 times before you hit the max number of groups. So you can only, like, your total runtime will just be n log n, because each time you double, you can only double 20 times before you hit the group, which means each node can only be added to a new group at most 20 times, and that's just worst case. You can't add every node to a group 20 times, or some node you won't be able to. But still, roughly, even if it's just 20n, that will still be fast enough. So we have to keep track of which group every node is in, and we have to add them to new groups in some quick way. So we can jump into code, start implementing that. So we're going to need a scanner. I'm going to call it FS. And then we're going to need to know int n and m. N is the number of people, m is the number of edges. So now we're going to need to know which group it's in. And then we're also going to need to know which things are in each group. So this will keep track, we'll have an array list for each group of all the things in it. And that way we can use that when we merge two groups to merge everything in that group into this new group. So initially, the group the ith thing is in is going to be I. And the only thing in the ith group is going to be itself. So then we're going to have m instances in which two people will talk to each other. So we're going to have the two people who talk. I guess we'll just call them A and B. And again, those are one indexed in the input. It's easier for us if they're 0 indexed, so we'll subtract 1 from both of them. And now if the group A is the same as the group of B, that means they're already frenemies, so we can just keep going. We don't really care about it now. We can't, we have to find the answer. We didn't really care. But if they're not in the same group, then well, then we have to merge them, and like we have to do some complicated work. So we're going to need to keep track of how many frenemies there are. Initially, it's going to start off as 0. And if they're in the same group, then we just want to print how many frenemies there are. Okay. If they're not in the same group, then we want to merge them somehow. And then at the end, we want to print out how many frenemies there are. Okay, so now we have to actually merge them. That's the tricky part. So the first thing we want to ask is, how is this going to affect the number of frenemies? Well, the new number of frenemies, like the number of edges we'll add, are all of the edges between the first group to the second group. So there are like however many things there are in the first group, that's how many choices we have in the first group, and then we have however many choices there are in the second group, choices for the second group. For every possible pair between the thing in the first and the second, there will be some new edge. So that means we will add the in group at whatever group the A is in. Well, actually, let's just make A whatever group it's supposed to be, and then B equals whatever group B is in. So now these are like the group numbers of A and B. So now frenemies can increase by the number of things in the other things group. We want to make sure we use longs here because the answer can get to 10 to the 10th and integers only go up to 10 to the 9th. So like 10 to the 5th squared will overflow integers in particular. So yeah, so we want to do that. And once we have that done, we have to maintain these array lists and also maintain which group everything's in. So now let's make A the smaller one. So if group, or if in group at A that size almost eclipse is bigger than in group at B that size, then alright, so then we can swap them. So now we know that A is the smaller of the two. Once we know A is the smaller of the two, then we can merge everything in A into everything in B. So that means we can iterate through everything that's in A's group. So the group of this thing is going to be B now, and then in group at B, we want to add this new thing, and then finally we want to clear everything that's in the group of A. So once we have done that, then we know that each thing can only be added 20 times. So that means this loop only runs 20 times n times total. Alright, so as far as I know, that seems to be pretty much the intended solution to Frenemies. This was almost solved by a team. They got really close. They just had a really tiny bug. They weren't using longs here. They're using ints. So then they have the wrong answer because it overflowed ints. They're printing negative numbers. But it was a pretty tricky problem. A lot of teams didn't see that it could be n squared, or they just thought maybe the data was weak. So they tried it anyway. But yeah, so that passes this data. The real question is whether it runs fast enough, and I'm pretty sure it does. I've got the data, but I won't run it here in front of you guys because it's kind of boring. Basically, the important thing is if you always merge the smaller thing into the bigger thing, this will happen log times. As a side note, you can use a disjoint set to merge two groups, and if you do that, you can cut down from log to inverse Ackermann, which is basically 5, worst case ever. So that makes it even faster. Disjoint sets are also pretty clean, and they don't require all of this complicated work here. You don't have to, you can just use a disjoint set for all of this, and it'll handle it for you. So that's like another thing. If you know about it and you want to use that interesting knowledge, you can. But obviously it's not necessary, and this is like some stuff that if you were really smart, you could like hypothetically come up with. Like it's a very difficult thing to come up with on your own, but if you've maybe seen stuff with like it before, or you've thought about it for a bit, or you are just really smart, it's like hypothetically possible to come up with something like this on your own if you have enough time. And it's definitely something you can understand even if you haven't been taught high-level data structures and algorithm stuff before. So yeah, so this is a solution to Frenemies. Hopefully you enjoyed it. I thought it was a kind of interesting problem. I liked it. And we'll see you in the last video, which will be on planes, which no one even tried in the contest because it was so scary. But it's really not that bad. You should hear the solution to it because it's kind of cool. So thanks for watching. See you later.